Imagine sending an important message to a friend. You know that some letters might get damaged during delivery. Wouldn't it be smart to add a little extra information so your friend could still understand the message? That's exactly what communication systems do. Before transmitting data, they often encode it to make communication more reliable. In the previous lesson, we learned how communication systems convert binary bits into physical signals that can be transmitted through electromagnetic waves. However, another challenge immediately appears. Communication channels are never perfect. Noise, interference, attenuation, and signal distortion can change some of the transmitted bits before they reach the receiver. Even a single incorrect bit may corrupt an entire file, image, or message. This raises an important engineering question. Instead of transmitting only the original data, can we organize the information in a smarter way so that transmission errors can be detected or even corrected? The answer is the concept of encoding. Encoding is the process of converting information into a structured format that makes it easier, safer, or more reliable to transmit through a communication channel. In digital communication, an encoder processes the original bit stream before transmission. Depending on the system, the encoder may add carefully designed redundant bits that help the receiver detect or correct transmission errors. After the encoded data travels through the communication channel, the receiver uses a decoder to interpret the received bits and recover the original information. If some bits were corrupted by noise, the decoder may still reconstruct the correct message. Encoding, therefore, improves communication reliability without changing the original information itself. Intuitively, imagine mailing an important document. Instead of sending only one copy, you include additional instructions or duplicate key pages. Even if part of the package is damaged, the recipient still has enough information to recover the original document. Physically, consider sending a text message through a cellular network. Before the message is transmitted, the communication system passes the binary data through an encoder. Extra redundancy is added according to a predefined coding scheme. As the signal travels through the wireless channel, some bits may be affected by noise. At the receiving phone, the decoder analyzes both the original and redundant bits to determine the most likely transmitted message. Mathematically, encoding introduces controlled redundancy into the bit stream. Although this slightly increases the amount of transmitted data, it greatly improves the receiver's ability to detect and correct errors caused by the communication channel. Encoding is used in virtually every modern communication system: Wi-Fi, LTE, 5G, satellite communication, GPS, Bluetooth, fiber optic networks, and deep space communication all rely on sophisticated encoding techniques to achieve reliable data transmission. Without encoding, modern high-speed communication would suffer from frequent transmission errors, especially in noisy wireless environments. Engineers carefully choose coding schemes based on channel conditions, data rate requirements, processing complexity, and desired reliability. For RF engineers, encoding is a key technology that works together with modulation, digital signal processing, and RF hardware to maximize communication performance while minimizing transmission errors. Encoding demonstrates an important principle of communication engineering. Reliability is achieved not only by improving hardware, but also by processing information intelligently before transmission. A common misconception is that encoding encrypts or hides information. In reality, encoding is primarily designed to improve transmission reliability, while encryption is used to provide security and privacy. These are completely different processes, although both operate on digital data. Now that we understand how communication systems protect transmitted information, we can examine what happens when errors still occur. In the next lesson, we will explore channel errors and discover why communication channels inevitably introduce bit errors and how engineers measure and manage them. In this lesson, we learned that encoding organizes digital information into a structured format that improves communication reliability. We also saw how adding carefully designed redundancy allows receivers to detect and sometimes correct transmission errors caused by imperfect communication channels. In the next lesson, we will explore channel errors and discover why communication systems experience bit errors and how engineers design systems to overcome them. If you found this useful, like the video, subscribe, and follow for the next lesson.